Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. Today we will continue the optional exercise that we started in the last lecture. Diagonals AC and BD of a quadrilateral ABCD intersect each other at P. So let us take any general quadrilateral ABCD and the diagonals of this quadrilateral BD and AC intersect each other at this point P. Okay, and we need to show that product of areas of APB and CPD, that is product of this area and this area, is equal to product of areas of APD and area of BPC, that is this area and this area. So the simplest way to do is you drop a perpendicular here and drop another perpendicular on this side. Why do we require to drop perpendiculars? To calculate the respective areas that we want to calculate. So let us first of all deal with the left hand side. We require area of APB. What is area of APB? Let us look at it. Let us name these as M and N, let us say. Okay. For area of APB, if I consider BP as my base, then AM will be the height, right? That is why we dropped these perpendiculars. So area of APB is equal to half into PB into height AM, right? The perpendicular is outside the triangle. And what is the other area that we have on the left hand side? Area of CPD, and it is equal to half into base into height, right? So look at this triangle CPD, that is this triangle here. So if I consider DP as my base, CN will be the height. So half into base DP into height CN, right? So the left hand side is product of these two areas. So these two areas, right? If the right hand side is also of this form, then we can say left hand side is equal to right hand side. So let us consider right hand side now. Area of triangle APD is equal to APD. So if I take DP as my base, AM will be the height. So half into DP into AM is the area APD. And what is area of triangle BPC? It is equal to, if I consider PB as my base, then CN will be the perpendicular. So half into PB into CN. And right hand side is nothing but product of these two areas. So it is product of these expressions, this and this. Now you can compare this. This product consists of half into half. So this also has half into half. PB AM DP CN. PB AM DP CN. So these two products are equal. Okay. Hence from here I can say left hand side is equal to right hand side. Hence proved. Okay, so it was just a simple application of area of a triangle, half into base into height. We just dropped two perpendiculars and taking these two perpendiculars as heights of these triangles. For example, AM is height for ADP as well as APB, right? So considering these, we could easily show that these two products are equal. Let us move to the next one. PQ are respectively the midpoints of sides AB, BC of a triangle. So first of all, let us draw this triangle, then understand this problem. A, B, C, P and Q. So P is the midpoint of AB and Q is the midpoint of BC. Okay. And R is the midpoint of AP. So R is midpoint of AP. Right. So now you understand. R is midpoint of AP. So if let us say this length is A, small a, right? Then this length will also be small a, and AP is 2A, that means BP will also be 2A. Why am I writing these? So that you can visualize how you can compare these segments, okay? And Q is the midpoint of BC. So if this segment is B, then this segment will also be B units in length, right? Now see, show that area of PRQ, area of ARC. Area of PRQ is half of area of ARC. So let us first of all join these. P with Q, R with Q. So now you have triangle PRQ. For triangle ARC, let us join these. Okay. So now we have got triangle ARC, triangle PRQ, right? So let us proceed now. First thing, P and Q are respectively the midpoints of sides AB and BC. So we have studied about midpoint theorem, which says that this length PQ is half of this length AC. PQ is half of AC and parallel to AC. Why? Midpoint theorem. We have studied about it, we have talked about it enough. Because if you join the midpoints of any two sides of a triangle, then the line joining these midpoints will be half of the third side of the triangle and will be parallel to it. So PQ is parallel to AC and PQ is half of AC as per the midpoint theorem. Now what I am going to do here is area PRQ, area ARC, area RQC, PBQ. I am not going to calculate these areas separately. What I am going to do is I will compare all these areas with the area of this bigger triangle ABC. Okay, so let us say area of triangle ABC is X units. And what are the units? These are square units, right? Let us say this is the area of triangle ABC. Now to locate area or to find area of PRQ, let me first of all find this area. Let me also join AQC. Okay, I have just joined A with Q. Right. Now let us start. Area of triangle ABC is X square units. So can you tell me what will be the area of triangle ABQ or area of triangle AQC? AQ is the median for triangle ABC, right? Because Q is the midpoint. So it will divide this triangle ABC into two halves in terms of its area. So these two areas are equal to X by 2 each, right? So AQC, this triangle, has got area equal to half the area of triangle ABC, that is X by 2, right? And same about AQC and ABQ. Now AC and PQ are two parallel lines, this line and this line. Okay, so what will be this area? If I join P with C, what will be area of ACP? Area ACP. It will be equal to area AQC because these two lie between same parallel lines and on the same base AC. So APC is also equal to AQC and hence equal to X by 2. So this area is also equal to X by 2. Now that we have got area of APC, what can you say about area of ARC, let us say? Now see, CR is median for triangle APC. Let me write it somewhere. CR is median for triangle APC. So what can I say about these areas? Area of triangle ARC equals area of triangle PRC equals half of APC. And what is APC? Area APC, x by 2. And half of area APC is nothing but x by 4. Right? So I'll compare all these areas with triangle ABC. Right? It has got area x, and I am calculating the areas of rest of the triangles. So now I have to compare PRQ with ARC. So I have got ARC with me, but I still haven't got PRQ. What is PRQ? This area is PRQ. This is the triangle PRQ. PRQ. Look, PRQ is nothing but half of APQ. Area of triangle PRQ is half of triangle APQ. Why? Because if you look at this triangle APQ, QR is the median. Because QR is median in triangle APQ. Right? So PRQ is nothing but half of APQ. Okay? And APQ is half of ABQ. APQ is half of ABQ. Why is it so? Because QP is median for ABQ. QP is median in triangle ABQ. Right? You need to watch this very, very carefully, because once I am through with this, every question, every part of this question will be solved. So APQ is half of ABQ. And what is ABQ? ABQ is half of the bigger triangle ABC. So ABQ is nothing but x by 2. So APQ is equal to x by 4, and PRQ is x by 8. Okay, now I need to compare PRQ with ARC. PRQ is x by 8. ARC, where is ARC? ARC is x by 4. So ARC is just double of PRQ. So I can say area of triangle PRQ is half of area of triangle ARC. How did I get this? By comparing it with bigger triangle, area of ABC, that I considered as x. So I found that area of PRQ is x by 8, area of ARC is x by 4. So it is area of ARC is double of area of PRQ. So the first part is done. Let us look at the second part. Area of RQC, and we need to compare it with ABC. So we just need to show that RQC is 3 by 8 of x in area. We need to show that RQC, area of triangle RQC, is 3 by 8x units. Now let us see what is RQC area. RQC. RQC is nothing but half of RBC, because RQ is median for triangle RBC. If you can notice, RQ is median for triangle RBC. RQ right? So what I can say about it, that RQC is half of RBC. And what is RBC? RBC has got triple the area of ARC, or in other terms, let me tell you, the bigger area was how much? It was equal to x, right? So AR and RB has got a ratio of 3:1. So RBC will have area 3 by 4x, right? What I mean to say is, let us say there is a triangle and I divide its base into two parts, right? Let us say this part is 1 and this part is 3. So this part will have 1/4 of the area of this bigger triangle and this part will have 3/4 of the area of bigger triangle, right? Why? Because the altitude in both the cases is same and the bases are in ratio 1:3, right? So their areas will also be in this ratio 1:3. Hence this area will be 1/4 of the total area and this rest of the area will be 3/4 of the total area. Now see, AR is to RB. I have shown you that these are 1:3 in ratio. So RBC, area of RBC will be 3/4 of the total area. That is X, area of RBC will be 3/4x. And what is area of RQC? It is half of RBC. So area of RQC will be 3/8x. That is what we need to prove here. Okay. Let us look at the next part. PBQ and ARC. Where is PBQ? This is PBQ. PBQ, if you notice, we have already shown this also in case of midpoint theorem. See, in midpoint theorem we have shown that this area is 1/4 of the total area. So this area will be, if total area is x, this area will be x/4. Why is it so? Because this side, if you look at this triangle, the sides of this triangle are halves of the sides of bigger triangle, right? So the comparison of area will be that its area will be 1/4 of the area of bigger triangle. Okay, we have shown it in various ways in the previous lectures. You can refer the previous lectures that this area will be 1/4 of the bigger area. So similarly, this area, that is area of PBQ, will be 1/4 of the ABC. So x/4. So PBQ is x/4. This is what we know from our previous knowledge. Okay. And what is ARC? ARC, I have already shown that it is equal to x/4. Hence, area of PBQ is equal to area of ARC. Okay, I hope you have understood this question and how to bifurcate or how to split this question into a lot of questions. What is done in this question is, it is just a mixture of question on midpoint theorem and area between two parallel lines and on the same base. And the third thing is that when we divide a triangle into many triangles, or let us say if we divide this base in many parts, we have discussed about it that if I divide it into n parts, the each area that I have here, let us say this area, will be x/nth of the bigger area. If bigger area is x, then it will be x/n. If I divide into n equal parts, right? In case of median, let us say this is median, it divides it into two equal areas. If I draw another line which is median for this triangle, now this line will divide it further into two equal areas. So if the bigger area was x, then this area will be x/2 and this area will also be x/2. So their halves will give me x/4 here. So these concepts are used in this question. I have not written all these steps because I just wanted you to understand this question. You don't have to write these steps because this is not a board level question. If it comes in a competitive examination, you just have to click the answer. Okay. ABC is a right triangle, right angle at A. So this is the right angle. BCED, AAC, FG, ABMN are squares on sides BC, CA, AB respectively, which can be seen in this figure. Line segment AX is perpendicular to DE, so this is 90 degrees, and meets BC at Y. So this angle will also be 90 degrees because BC and DE are parallel lines, right? Because these are the sides of this square BCED, right? Now we need to show that triangle MBC and ABD are congruent. So I may not write all these steps again, but I will make you understand this. Look at triangle MBC. This is triangle MBC, right? And there is this angle enclosed between MB and BC, okay? Which is the other triangle ABD. So this is ABD, and then there is this AD. Okay, if you look at these two triangles, MB and AB are two sides of the same square. Similarly, BD and BC are same sides of the same square. BC and BD are sides of the same square, hence these are equal. Similarly, MB and AB are sides of the same square, hence these are equal. And what about angle between them? Look at this. First of all, for this congruency, let me write MB is equal to AB because squares sides, right? What about other side? BC is equal to BD. Again the same logic, right? You can mention the square also. For example, in the first case, in this case, the square I am referring to is ABMN, right? In this case, I am referring to BCED. Okay, I hope you have understood that. Now, look at the angle between MB and BC. MB and BC, we have got these angles. This angle, which is 90 degrees, plus this angle. If I consider this angle, let us say theta. So between MB and BC, we have got 90 plus theta. 90 because it is a square. Theta, I have named it theta. Okay. Now look at angle between AB and BD. AB and BD also have got this theta and this 90. So angle between AB and BD is also theta plus 90. These two angles are same. So two sides are equal, right? Two corresponding sides are equal. Angle between those sides or angle included between those two sides are equal. So by side angle side congruency rule, this relation is true. That is, triangle MBC is congruent to triangle ABD. Okay, so I am not writing any further details. I hope you have understood this. Okay, so I equated the two sides and the angle included between those two sides. Now look at this. Area BYXD. So what is BYXD? This is area BYXD. Is double of area MBC. Okay. So let me first of all clear this diagram. Now I'll show you. See, BYXD, this area, and MBC, how are they related? You need to find something common in these two. Okay. So let us look at it. BYXD is double of this area, BDA. Why? Because triangle BDA is lying on the base BD and between these parallel lines AX and BD, because this angle is also 90 degrees, right? And BYXD is a rectangle which lies on base BD and between same parallel lines BD and AX. So area of rectangle BYXD is double of area of triangle BDA. This is something we understand. Okay, now look at this. I have already proved congruent to MBC. So it will have area equal to MBC. So I can say this is equal to twice of area of MBC. This is what I had to prove. So after once you prove the first part that MBC and BAD or ABD are equal in area, now you just have to show that BDA is half of BYXD because they lie on same base BD and between same parallel lines AX and BD. So the area of this triangle will be half of area of rectangle. Okay, so the second part is also proved, right? Now look at the third part. BYXD and ABMN, how are they related? Similarly, these are equal. Why? Because MBC and BAD are equal in area, right? The first part says that MBC and ABD, these are equal in areas. So ABD is nothing but half of BYXD. ABD is half of BYXD. Why? Because same parallel lines and same base. So the triangle will have half the area of the rectangle. Now look at this. MBC and MBAN lie on same base MB and between same parallel lines NC and BM. So MBC will have area half the area of ABMN. So if half of ABMN is equal to half of BYXD in area, then their doubles will also be equal. Hence the third part is proved. So what I used here is that MBC, that is this triangle, is half the area of, is equal to the triangle MBC has got area half the area of ABMN, and triangle BDA, that is this triangle, has got half the area of rectangle BYXD. So these are equal, and if the halves are equal, then their doubles will also be equal. Hence the third part is true. Let us move to the fourth part. Once you understand the three parts, I would recommend or I would suggest that you do the rest of the parts yourself, because there is nothing new in these parts, upcoming parts. FCB, ACE, these are congruent triangles. How? Look at this. FCB is this one, and ACE is this one. So AC is equal to FC. Why? Because these are same squares sides, right? And what about the other sides? BC will be equal to CE because these are sides of square BCED. So here what I can say is FC is equal to AC. FC equal to AC. Sides of square FCAG. Square FCAG, for your reference I am writing here, right? And what about other sides? Side CB is equal to side CE. And why is this true? Because these are sides of BCED, which is a square, hence the sides are equal. Now look at the angle between FC and CB. FC and CB has got an angle. Let us say this angle I know is 90 degrees. Let us say this angle is theta. So FC and CB has got an angle 90 plus theta, as I explained in the first question. Okay. So what is angle between AC and CE? AC and CE has got, this angle is 90 and this is theta. So theta plus 90 or 90 plus theta. So by SAS congruence criterion, this relation is true, or you can say triangle FCB is congruent to triangle ACE. Okay. And fifth part, CYXE FCB. What is the relation? CYXE. This is the rectangle CYXE, and we need to compare it with FCB. Where is FCB? This triangle is FCB, right? So how can we compare these two areas? we can compare these because as we did in the first part, right? As we did here, because we have already proved that triangle FCB and ACE are congruent, right? This triangle ACE and this triangle FCB, these are congruent, hence these have equal areas. Now these areas are halves of the areas that we are looking for, CYXE. That means the area ACE, area of triangle ACE, is half of area CYXE. Let me write it here. Area of triangle ACE is half of area of CYXE. Why? Because triangle ACE lies on this base CE and this rectangle CEXY lies on this base CE, right? And these two lie between these two same parallel lines, this line and this line. Hence the area of this triangle ACE will be half of area of this parallelogram or rectangle CEDY, right? CEXY. Okay. So ACE is half of CYXY. Now ACE I have already proved is congruent to FCB. So the area of FCB will also be half of CYXE. Okay, I hope I have explained it enough. So let us move to the next part, that is sixth part. Now this part is done. So let us look at this part, CYXE ACFG. Now you can easily compare these areas because this triangle CFB has got half the area of CFGA, that is this square, right? So if I can say this square has got double the area of CBF. This square has got double the area of triangle CBF or FCB, right? And this CYXE we have already proved has got double the area of ACE. This is nothing but double the area of ACE. Now look at this, ACE and FCB we have already proved are congruent, so equal areas, so their doubles will also be equal, hence this relation is also true. Okay, look at the seventh part, area of BCED, that is this bigger square, is equal to area of ABMN plus ACFG. This is very simple result because area of BCED consists of two areas, that is this area which is BYXD plus this area that is CYXE. So it consists of two areas which are equal to, BYXD is equal to ABMN. So you can simply replace this by ABMN here, and CYXE we have proved equal to ACFG, so you can replace it here. So the seventh result is nothing but a manipulation, or you can say that you just need to add third and fifth part. So you will get this bigger area BCED, right? So there is nothing new in the seventh part. Hence this question is done. I hope you have understood it well and you don't have any confusion in this chapter now. Thank you.